Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome again to Algebra 2 with Chapter 9, Lesson 2, Arithmetic Sequences. And this is the first part of the lesson. Our lesson is to define, identify, and apply arithmetic sequences. Here we have the sequence 3, 5, 7, 9, 11, etc. Sequence an ordered list of numbers. Arithmetic sequence, a sequence that follows a pattern of adding a fixed amount from one term to another. This pattern is called the common difference D, okay, represented by D. So what is the common difference here for this sequence 3, 5, 7, 9, 11? It's number 2. Difference between any two numbers of the sequence. 3 with 5, 5 minus 3 is 2, 7 minus 7, 7 minus 5 is 2, 9 minus 7 is 2, 11 minus 9 is 2. Okay? So D, common difference, n, the term number, an is equal to the nth term. So for the sequence 3, 5, 7, 9, 11, a1 is the first element, 3, and a2 is the second one, 5, a3 is the third one, 7, and a4 is 9, a5. How could we represent the sequence as a function table, a graph, and equation? So for a1 is equal to 3, a2 5, a3 7, a4 9, a5 11, and the values of n, the domain, let it be 1, 2, 3, 4. So an is the range 3, 5, 7, 9, 11. So graph the ordered pairs in the graph, in the coordinate plane, xy plane. We will get 1 with 3, 2 with 5, 3 with 7, 4 with 9, 5 with 11. Then connect between the points, we will get this line. So this is the graph of the sequence. Algebraic rules for the sequence 3, 5, 7, 9, 11. So we have the recursive rule. Each term is used to derive the next term. So we have a1 is equal, because this is the initial part of the recursive rule, and then we have the recursive formula, which is an is equal an minus 1 plus d, such that an minus 1 is the previous term and d is the common difference. For the explicit rule, we have allows you to find any term of the sequence. Okay, so this is the benefit of the explicit rule, allows you to find any term of the sequence. As we said, for the recursive rule, each term is used to derive the next term, but for the explicit rule, allows you to find any term of the sequence. Okay, so the explicit rule, an is equal a1 plus n minus 1 times d. So the an is the desired term, and a1 is the first term in the sequence, n term number, and d the common difference. Okay, so for is number 3. So we have the recursive rule, an is equal an minus 1 plus 2, such that 3, 5 times minus 3 is equal 2, so d is equal 2. And for the explicit rule, we have an is equal a1, which is 3, plus n minus 1 times d, which is 2. Okay, so if we want to determine a75 using the explicit rule, substitute a 75 is equal 3 plus 75 minus 174 times 2, it is 148, plus 3, it is 151. Okay, also we can use the formula an is equal to dn plus the difference between the first term and the second term. Okay, for this sequence 5, 9, 13, 17, 20. So for the table n is equal 1, 2, 3. For an we have 5, 9, 13, 17, 21. So we can represent the order pairs and the xy plane coordinate to get this line of a graph. For this sequence a1 is equal the first number, and for the recursive formula we can use this one, an is equal an minus 1 plus d, but for the explicit formula we can use another one, which is dn plus a1 minus d, because when we distribute d here we will get dn minus d, dn minus d. So a1 minus d plus dn. This is the explicit formula. We can use it to find any term of the sequence. For this sequence 5, 9, 13, 17, etc., we have the recursive rule is when we have a1 is the initial term, which is 5, so an is equal an minus 1 plus d, which is 4. And for the explicit rule, an is equal a1 plus n minus 1d, and a1 5, d is 4. So an is equal 5 plus n minus 1 times 4, which is 4n plus 1. To determine a50, substitute the value 50 instead of n. So we will get a50 is equal a1, which is 5, plus 50 minus 1, which is 49 times 4, to get 201. Okay, so we can also use 4 times 50, which is 200, plus 1, 201. For this sequence minus 3, 1, 5, 9. So if you see 9 minus 5 is 4, 5 minus 1 is 4, so the value of d is 4. Now for the recursive rule a1, it is the initial term minus 3, so an is equal an minus 1 plus 4 for the recursive rule. And for the explicit rule, if you want to find a80, so a1 is minus 3 plus n, which is 80 minus 1, 79 times 4. So minus 3 plus 79 times 4, which is the same dn, which is 4n, and minus 3 minus 4 is 7, minus 7. So 4 times 80 minus 7 is equal to 313. So this is the end of our lesson today. Thank you very much for listening. See you later inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.